Okay, hold on. If I start moving around, doing all sorts of crazy stuff, just make sure I look good. That's very easy. That is very shut up. I just told this student to shut up on camera.
Oh my, wait, can they hear what I'm saying?
But it was Roberto, so everyone understands. Alright. Things that need to happen. In the middle of the table, I see some people who already have the syllabus. Oh my god, so excited. Don't leave the syllabus yet. I don't want it. The only thing I want right now is summer assignment round 1 and round 2. In the event that you're about to give me some lame reason why you don't have it, I'm not listening to lame reasons. Summer assignment round 1 and round 2 are due, period. They are in the middle of the table. In the event that you did not complete all of round 1 and round 2, you're going to stop by during lunch so that we can talk about what my plan is for your getting this done. Go for it.
Can I just give you everything?
You can always give me more than what I asked for. Okay, so if you are done, because that's how you roll, round 1, round 2, round 3 are all done, put it in the middle of the table, make sure your name is on it. When's round 3 due? Tomorrow. Go for it. Do I have a stapler? Yes, there are lots of staplers. They're in the cabinet. They're not out here. So just like do a little like origami thing. Or just keep it all together neatly stacked. It'll be fine. Okay? Any other questions about paper pickup? My friend in the way back who has the best desk, I forgot your name. Andy. Andy, can you go around and pick up the assignments for everybody, please? And just leave it on my desk when you're done. More training is coming. Andy, can you commit to being the paper picker upper? Excellent. And Marilyn, can you commit to being the camera person? Excellent. Ebel, can you commit to being you?
No, I'm sorry.
All right, good.
Change it.
Okay, I also have a naughty list. This is the first one of the year. There will be more. It's the first one. There are 31 of you that for some reason did not respond to the email that I sent yesterday that said, please respond, send me your date of birth, send me a good phone number for you, and what something you've heard about the course, and your favorite TV show. Okay, check. I realize we are coming back into school mode. I understand. I need the 31 of you to stop by here during lunch with your phone so that you can respond to that email and I can cross you off the naughty list. Destiny, I think you didn't get it because I had the wrong email in there for you. I think I had Evelyn in there twice. Okay, so if you're not sure if you're on the naughty list, here comes the naughty list, Paul. Probably on the naughty list. All right. Evelyn, Jackie, and Destiny. Evelyn, ¿dónde está mi Evelyn? Next class period. Jackie. Okay, Jackie, this is a short-term loan. Destiny. No, but talk to me later about what we're going to do. All right. Summer assignment. Check. Pretty good? Are you good? I think I'm good. Okay. All right. Oh my gosh, so excited. So excited. DC kids, we're just roll. Keep going. Keep going. Everybody else, I need you to stand up, please. We're going to go back and do a little bit of power teaching. We're not going to do this every single day, but it is a good way to start the day. For those of you that have memories like goldfish, goldfish have a memory of about 10 seconds. That's why they can live in that little bowl. Every time they do a lap, they're seeing new things. Okay? So, we're going to look really good on camera. On the count of 3. For a limit to exist, the words are up here for those of you that don't remember.
That is good sign.
Count of 3. 1, 2, 3.
For a limit to exist, the limit from the right and the limit from the right must be equal to each other. A hole in the graph is okay, but jumps and breaks are not.
Well done. So I'm curious, why this? What is this supposed to mean?
They're equal.
We're finding the limit from the left and we're going to find the limit from the right, and we need them to be
Equal.
equal. Now, do we always find the limit from the left and the limit from the right, Paul? Sometimes we just do limit from the left. And you would know that because you'd see like that little negative sign after the number. Sometimes it's just the limit from the right, and you know that because of the little positive sign. How do you know when you do both? When there is no sign up there, right? So you're always going to check limit from the left and limit from the right, and if they're equal, then whatever they're equal, that's the limit. If they're not equal, what do we say?
Does not exist.
Limit does not exist because limit from the left, limit from the right, not equal. Next! Okay, hold on. Some of you going rogue. Okay. Limits can approach infinity. It is possible that I'm going to ask you what's the limit, and you're going to say, sir, the limit is positive infinity or the limit is negative infinity, and this is okay. However, the College Board likes, they prefer for you to write that the limit does not exist because of, anybody remember the phrase? Unbounded behavior. The College Board likes limits to be finite numbers. Numbers like 12, negative 19. So this one on the count of 3. 1, 2, 3.
Limits can approach positive infinity or negative infinity. The College Board wants us to say that these limits do not exist because of unbounded behavior.
Pretty good? Okay, one more. One more. You can't expect to teach more than 2 things in a day. All right. I want to take a look at this function over here, this bottom one. All right, or Paul, who's wiggling, emulating this function. If I asked you all, what's the limit as x approaches infinity? Which way is infinity?
To the right.
All 4 dimensions.
All 4 dimensions. Oh, we don't know what you had for breakfast. Okay. Infinity that way. Infinity would be this way, correct?
Yes.
Okay. If I said, what's the limit as x approaches infinity? Well, what the function is doing, right? It's bouncing. It's going up, it's going down, it's going back up, it's going back down. The fancy word for this is oscillation. What was the word?
Oscillation.
Say it with attitude.
Oscillation.
Say it so that the people next door are wondering what the heck's going on.
Oscillation.
Well done. When you see this behavior, we're going to say the limit doesn't exist because it's not getting closer to one particular number. It's what's it doing again?
Oscillation.
Oscillation, or those of you who are in like AP English, which is AP English for all, it's oscillating. Okay? So, as x approaches infinity, or as x approaches negative infinity, if the function does not approach one specific value, then the limit does not exist. This is another does not exist kind of situation. And the fancy word for this is oscillation. Saying it like a gangster. All right, on the count of 3, here we go, from the top. 1, 2, 3.
As x approaches infinity or negative infinity, if the function does not approach one specific value, then the limit does not exist.
Gangster style. The fancy word for this is
oscillation.
everybody good? Way to be there for me, Daisy. All right, good looking people, have a seat. Paul, you sit.
My lowest
All right. Today, we are going to focus on some new things. Yesterday was like baby style. We had the graph in front of us, life was good, you saw all the things. We practiced our limit skills, and some of you had a freak out moment. It's okay, you're in very good hands. I know what I'm doing. What I'm curious about today is how many things can I take away from you and you're still going to be successful? So for example, these first 10, I'm on the top of page 6 in the unit guide, and that unit guide comes every single day. You may also want your parent function survival guide for these. There are 10 different limit expressions here that I need you to evaluate. Let's do the first one together. Can I get, what's your name? Chris. Chris, can you read this first one out loud? Okay, we're on page 6. The limit of of 1 over x as x approaches 0 from the left. You don't have the graph in front of you. However, I would hope that for most of you, the graph of 1 over x is a parent function that we're familiar with. It's been a while. Can you guys sketch it in the air for me? I'm a big fan for like drawing in the air. What would that look like? Look at the folks around you. What are they drawing? 1 over x. Some of you are drawing it right. Some of you are like, oh my God, why? How many of y'all are pretty confident you know what this graph looks like? Okay, that's like 5 or 6 people. The graph of 1 over x, if you're not sure, looks like that thing. What did you call it? And you didn't know. So this is the graph of 1 over x. If this is the graph of 1 over x, what's the limit as x approaches 0 from the left, everybody?
Negative infinity.
Coming in to get close to 0 from the left, the y values are decreasing. We're heading down towards negative infinity. So negative infinity is a great answer. What does the College Board want you to write? Does not exist because of unbounded behavior. Everybody good? You've got 5 minutes. You can work with your friends. For those of you that don't have friends, you can work with the people near you. Okay. Your goal is to get through all 10 of these. They are going to get tricky. Some of these are not functions you're familiar with, and that's okay. You can use your parent function survival guide if you need to. We'll talk in 5.
Wait.
Yep.
So we put
For my, I would accept both, right? The limit is x approaches 0 from the left is negative infinity. The College Board would prefer that you would write doesn't exist because of but you'll never, like on multiple choice, you'll never see both. You're never going to be in a place where you just choose between the two. They'd either say negative infinity or doesn't exist because of unbounded behavior.
Wait.
Makes sense? I'll take
function survival guide.
So you could write doesn't exist, does not exist, but then always tell me why. Doesn't exist because unbounded behavior. Okay? Love it. Seeing the survival guide out there. 3, 7, 11, 15, 18.
If it wasn't for this piece of paper, I would have died.
3, 7, 11, 19, 23, 8.
Paper saves my life.
Okay, so you know this one also does not exist because of what is that called? Oscillation.
That's not a
No.
word.
Oscillation.
Oh, yeah.
The word is oscillation, not isolation. Andy is in isolation.
Who's in isolation?
Eval will probably move into isolation at some point.
Now this one is negative 15, but it does not exist. The number.
How do you spell oscillation?
Oscillation.
Oh wait, I totally know. I mean,
Are you serious?
yeah.
Wait, does not exist.
Spelling rules. Not everyone's perfect. Spelling rocks. Alright, 0.
This is
INX.
this is negative infinity, but does not exist.
Now you're not on. Are you sure it's negative? But it stops right there. So,
Is this unbounded behavior or is it when it's positive and negative? That's only when it's
Not anymore.
whenever it's infinite
parent function has no type with you. It doesn't say.
Oh, 2 minutes. Those minutes are lost.
So it's another does not exist.
Paul, you got a question?
Yes, that's what I think.
Excellent. What a great question. Yes, you will have all these parent functions memorized. Trust me, I do such a good job. I mean, I've been told. OSC.
So you haven't seen any more?
You know what?
And I promise anybody who spells the word oscillation wrong,
You know what? You know what? I'm tired of this.
it'll be okay.
Also, an eraser.
It didn't sound so much
Wow, this is like lost. Look, this one is this one. I was asking myself, why am I not in C? Oh, and I took a nap. I was like, why am I not in C? Now I understand. I'm not on that grind. You see Ruben here, he's staying on that grind. I can't find EX. You heard him? He said, isn't E the same thing as probably not.
I think it's this one.
I actually skipped that one. And I skipped this one. I know but he came more like E A.
You know this one? This one is this one.
So I would say does not exist because of oscillation.
For the E, does it matter if it has like more variables?
Yes.
So
Alright, friends. Let's take a peek. Oh my goodness. I think I lost my solutions over there. So awkward. So awkward. Alright, so the first one, we've already agreed limit as x approaches 0 is going to be negative infinity. Or does not exist. Why was that again? Unbounded behavior. Unbounded behavior. Limit as x approaches 0 from the left of 1 over x squared. If you don't know what the graph of 1 over x squared looks like, it's in the parent function survival guide. We're going to do so much with this week, you will know 1 over x squared looks like this. So what's the limit as x approaches 0 from the left? You could say positive infinity. You could also say does not exist. Unbounded behavior. Let's avoid abbreviations like UB. I don't know what UB. Okay, limit as x approaches infinity of sine of x. Sine of x, you guys know what that graph looks like. This is another does not exist. But the reason?
oscillation.
Oscillation. Limit as x approaches 0 from the right for the natural log of x graph.
Does not exist.
Right. Negative infinity or does not exist. Unbounded behavior. Limit as x approaches negative infinity of e to the x is going to be 0. Limit as x approaches infinity, 1 over x squared plus 1. This, again, not one that I expected, Adrian, you would just know off the top of your head. But you looked it up in the survival guide. You guys all found it. And the limit as x approaches infinity is 0. Limit as x approaches 0 from the left, absolute value of x over x. Not a parent function that you knew already. Looked it up. And what you should see is the graph looks kind of like this.
Yes.
Just two horizontal lines.
Yes.
Limit as x approaches 0 from the left is -1. Limit as x approaches 0.
1.
I've heard 1. I've heard does not exist. What do you think?
I had a question.
Yeah.
Why is it 0?
Why is this guy 0?
Yeah. Like it's aligned to me that one.
Well, the graph of 1 over x squared plus 1, if you're looking at the right graph,
Yeah.
it looks like that.
And it means like they both like plus 1.
But as x approaches infinity, you're heading out towards the right. The y values are getting closer to 0. You have a horizontal asymptote. Hold that thought for a little bit. Okay, last one that we're going to talk about right now. Limit as x approaches 0, absolute value of x over x. This does not exist. does not exist because the limit as x approaches 0 from the left is not equal to the limit as x approaches 0 from the right. I'm not going to worry about 9 and 10 right now. Okay, I'm curious. How are we feeling about problems like this when the graph is in front of you? If the graph is in front of you, we seem to be doing mostly okay.
Yes.
It is mission critical that you spend some time with the parent functions and you really get to know them. For the next 3 days, we're going to keep coming back. We're going to do a lot with the parent functions so that it just pops all the time. Develop.
How does the EX look like?
E to the x looks like that. Okay, friends are good? Alright, so I told you I'm going to keep taking things away from you. Not because I'm evil, but because I have high expectations. Here's the next thing that gets taken away from you. Your knowledge of the graph. Okay, and I'm going to work with Mr. Harper so we figure out the right way to set up the boards here. So what I need you guys to do is take out your calculator. And that's okay, I know everybody has it because we were told that we needed to bring it today. And this is how we roll at Southwest. Andy, if you're going to sit here, then I'm going to need you to be the person who drives the calculator. Are you okay with that? All right, Andy is going to drive the calculator. I need to be patient. It was connected. I even tested it. There we go. All right, so I'm going to assume that for most of you, your calculator hasn't seen much action this summer. Okay, I am thrilled to see that just about everybody has their calculator out and ready. Oh my God, actually everybody has their calculator. Oh, well done. I need to have higher expectations. Okay, so what we want to look at, this very first one says, limit as x approaches -2, is it x cubed plus 8 over x plus 2?
Yes.
Okay. Limit as x approaches -2, x cubed plus 8 over x plus 2. What ideas are out there?
There's a cube on the top and then just a X on the bottom.
I do see that there's a cube on the top and there's an x on the bottom.
Remember they said something about like if there's a higher exponent in the bottom, I guess you subtract it.
Okay, you've got some thoughts, and we're referencing back to Mr. Link. We miss you. Yes, Mr. Link told you something about exponents and looking at the degrees and kind of drawing some conclusions from that, but that is only if we're dealing with asymptotes. If we're asking about limit as x approaches negative infinity and x approaches positive infinity. And that's not what we're doing here. What other ideas are out there? Thanks for getting in there. Daisy.
I think you probably could factor the top one, the sum of cubes.
Way to go. I didn't think anybody was going to get to that yet. Everyone else is like, yeah, Daisy did. How about all the rest of us? Depending on your comfort with algebra and factoring, you might see this as not x cubed plus 8, but x cubed plus 2 cubed, which is a sum of 2 cubes. And there's some factoring you can do there. I'm going to assume that that was for Daisy, and everybody else is like, I have my calculator, help me. Does anybody know what the graph looks like? X cubed plus 8 over x plus 2? I don't know what the graph looks like either. So let's find out what the graph looks like. Okay, Andy, for all the friends, we're going to go a little bit slow here. Andy, can you hit the home button, top right? Okay, it's been a while. Let's make sure they're all on the same page. Let's hit page here. Hit the graph. So option D. There you go. And I want you to arrow up so it says F1. You guys should all be typing this in the calculator as well. Arrow up. Arrow up, please.
It's not working.
It's not working.
Oh,
Hey, look at that. You already typed in x cubed plus 8 over x plus 2. I need you guys to all get the graph of x cubed plus 8 over x plus 2 in there. Yes. If for some reason your calculator is doing something like really fancy, hit menu. And then you want to do graph entry, and then function. Because I think for some of you, your calculator is in polar mode. Okay. Once you've got this typed in, hit enter, please. Okay, Andy, hit tab again.
Let's see.
And can you hit tab? Tab, there you go, arrow up. Andy, hit tab. Arrow up. And then click on that little box there. There you go. Hit enter. Clicking on the box. Hi there.
Hello.
Hitting enter.
They don't fix it.
That's, I know, this is the first time Andy has graphed. Is everybody else able to graph this?
Yes.
Okay, so it's just Andy.
Okay, hold on. We're going to do that.
Okay, it may not be just Andy. There we go. Ah, it was just Andy. All right. If I can pull everybody back together, we've got calculators, we've got graphs. Andy has a graph. We all have a graph. So here's the question. Andy, if you can hit escape, please. There you go. We've got the graph. But the question still is to figure out what's the limit as x approaches -2. I want to get some hands on this. What could you do? What can you do with the calculator to figure out what the limit as x approaches -2 is? I see one person, I see two, I see three. Jackie, what are your thoughts?
Couldn't we like do a little zoom in on our part? Like we need to zoom in on our part so that we're looking for 2 going from the left side. We could get.
Well, hold on. Are we saying limit as x approaches 2 from the left?
Oh no, I'm kidding. It was -2.
We're looking for like what's the limit as x approaches -2?
Yeah.
You can go on the calculator and trace, just plug in -2 and then.
Does everybody hear that?
Yes.
Right, so you could trace -2. I want to show you another way, and I don't think Mr. Link ever showed you this way. What I want to do is I want to add a table. Andy, hold on. Andy, hit escape. Okay, I want you to hit Control T. Control T is going to add a table. Control T, good. Next magic trick, we're going to hit menu. And the instructions are in the handout. Click on table. And edit table settings. And finally, switch the independent variable to ask mode. All right, okay. Click OK. What this allows you to do, you've got the function, and what I want to do is figure out what happens to the y values as we get close to -2. So, somebody get me started. My goal is to get close to -2. What's a good place to start? -5. Great, so let's type in -5. Now, my goal is to get close to -2, and he just told me -5. Paul, can you get me closer? -1.9 is closer to -2. Is everybody okay with that?
Yes.
So -1.9. Can anybody get -1.9? Andy, get enter. Okay. Can anybody get closer? Yes, ma'am. -1.99. Type that in. -1.99 is closer to -2 than -1.9. Can you get me closer? Develop.
-2.001.
Now I want to be careful. -2.001, you've like crossed over, right? So if we've got our number, if we're thinking about our number line, all the numbers that we're using right now, we're approaching -2 from which way?
On the right.
From the right or the left?
Left.
Right now, they're all approaching from
The left.
the left.
The right. The right.
The right. right? We had, oh yeah. Yeah, we went all over the place there, didn't we? We had -5, and then we had -1.9, and then we had -1.99. Get me closer, like -1.999. What I'm looking for, before you declare an answer, I'm looking for, it was called stabilization. I'm looking for 3 places after the decimal to stop changing. So let's try -1.999. Hit enter. Now we've got 11.994. What are we getting closer to? 12. Getting closer to 12. Don't say that it's 12, that the limit is 12, until you've seen stabilization of the first 3 decimal places. So get closer. Maybe you want to, Andy, try like -1.9999. Be careful, you want to get the negative. 1.9. Ooh. Okay, hit enter. 11.9994. What are we getting closer to?
12.
12. Do we have stabilization in?
Yes.
Stabilization means the 3 places after the decimal aren't changing anymore. And if you look at what you typed in just before this to what we have now, we still haven't stabilized. So get a little bit closer. Your calculator can handle it. It keeps running your it keeps rounding your numbers. Right, so -1.999, hit enter. Anybody else seen that? -2. In the cell, it says -2, but if you arrow up, Andy, arrow up, just that one, the actual value is down here in this cell. And what we're getting closer to is this 11.999. Now be careful, because some of you are going to be tempted to say 12. Have a conversation with somebody near you. Why should you not be saying right now that the limit is 12? Don't talk to me, talk to your neighbor. Spoiling all my fun. So this is our all the BC friends, all the AB friends, and then the rest of the world.
Does it have a -2 there?
Okay. So walking around, I heard from 5 different groups that the limit looks like it's going to be 12, but it's too soon, because what I just heard loud and proud was, why is it too soon to say that the limit is 12?
You gotta look at both sides.
We have to look at both sides. The only thing I can conclude right now is that the limit as x approaches -2 from which side?
Right.
The right side is actually 12. I need you all to convince me, so finish convincing me. Yes, ma'am. That's a conversation for a different day. Right now, just convince me. Use those newfound calculator skills. Convince me that it's 12.
You go like -2. 0, 0, 0. 1.
Well, I thought he said we couldn't go over.
On the left.
And Andy, if it gets to a point where you're like, no, this is not for me, I'll trade you out. Right, your goal is to get closer. What's your goal? You're trying to get closer to -2. So I see you typing in 2.01. 2.001. That's all the way over there. We need to get closer to the -2.
Oh yeah, negative.
There you go.
Your wife has to read it in there.
You're so tempted to come over here. No, not there. We're good. You already get 12? Hit me. So you put in -2 and you got undefined. I'm not asking what is the value in -2, what is the question we're asking? What's the limit? What happens as you get close to -2? Don't actually plug in -2, the function's going to have a problem.
Retrasados, no,
All right, friends, quick show of hands here. How many of you guys have it? Like limit from the left and limit from the right, both coming out to be 12. We got this, we got newfound calculator skills. All right, next problem. I want you guys to try option B. It is a new function that you're going to have to type in. There's going to be a challenge. We're going to talk in a minute. Andy, if you could get all the things set up, that would be great. And if you want to get rid of this table, hit Control and T. It'll make the table go away. Are you sure you want to delete everything? Yes. Okay. Now let's put this in. We're going to encounter a different problem. All right, Andy, what are you trying to do? Okay. The fraction thing.
It's the sign. It's this one.
Oh, okay. Okay. If all goes well, your graph is a straight line.
Yeah.
Good. Now, here's the question, though. What's the limit as x approaches the square root of 2 of x squared minus 2 over x minus the square root of 2? What's that limit as x approaches the square root of 2? What I've seen so far is a lot of people, they've set up their table. So Andy, you can do Control T again. So we can get that table back up there. You've got a new function now. Unfortunately, your calculator has decided like 1, 2, 3, 4 are the numbers. So we need to fix it again. What were the steps? Menu. Table. Settings. Switch it to ask. And then auto. Now, here's going to be a little bit of a problem. There's the square root of 2. Can somebody get me close to the square root of 2 from the left? Not as many people willing to volunteer. And I think it's because we're not as comfortable with a number like square root of 2 as we are with like 2.